Several of you mentioned having difficulty with composite functions, which is in lesson 11. And so I'm going to work through some example problems from the textbook. They're in section 3.4 on page 220. Your assignment was to do the odd problems, and I'm going to work through some of the evens so that you'll still have some to practice on. So the first few problems have to do with doing composite functions where you have a table. One of the things you have to remember about a composite function is that it's a sequence of operations or a sequence of functions on your problem, and typically it's written in the form f composed with g at x. Now, what this means is basically you can think about it almost like getting out of jail. You start with your variable and you input it into the closest function. So we're going to substitute x into function g, get an answer. Once you get the answer, you take that answer and you plug it into function f. Okay, so that's how it's kind of usually written, and the thought process. And so when you're doing that with a table, there's really not a lot of calculations involved. It's just simply a matter of reading the table. So question number 58 is f composed with g at 8. So my input value is 8. Okay, so the 8 here is my x value. And so I'm going to look at my table and find 8 on the x, and I want to know the value of the g function. So the value of the g function would be 4. So g at 8 is 4. That value of 4 now becomes my input. See, I've gotten this answer as 4. And now I'm going to substitute that into function f. So now I need to find where my input is 4. See, this becomes my new input. And I need the value of function f at 4. And that happens to also be 4. So f composed with g at 8 has a value of 4. Okay. Again, it's a sequencing event, and you have to pay attention to the sequence. Using the same table, question 60 asks us for g composed with f at 5. And so that means the x here, our input, is the 5. So this is x, our input, and we're going to input that into function f. So I'm going up to the table. When x is 5, function f has a value of 0. So f at 5 is 0. So I get that answer. Once I get that answer, I take that answer and plug it into function g. So that answer of 0 becomes my input. When I input 0 into function g, I get an output of 9. So g composed with f at 5 has a value of 9. Same table, question 62 wants us to do f composed with f at 4. Again, your input, your starting value is 4, and we want to start by putting that into function f. So when I plug, if my input is 4, my x is 4, I plug that into function f, I get a value of 4. Okay, this one's kind of redundant. Okay, so I get a value of 4. That value of 4, now that I have that value, I take that answer and plug it into F. So my output was 4. That becomes my input. And when I plug 4 back into 4, I get 4. So F composed with F at 4 has a value of 4. And then question 64 says G composed with G at 2. So my input is 2, that's the X, and I'm going to substitute X into G. Okay, so when X is 2, G has a value of 6. So G at 2 is 6. When I get that value, get the answer, I plug it into function G again. So I'm going to plug 6. My output becomes the input, so it's 6. And at 6, the value of function G is 7. So G composed with G at 2 is 7. Okay, so when you're doing a composition and you're using a table, it's just a matter of reading the table. The primary thing to remember is to follow the order of operations, or follow the order of the compositions, excuse me. You need to start with the input value and work your way, in a sense, backwards. You can also do compositions using graphs. Okay, so here's 2 different graphs. You have the top graph, which is the parabola, is function F, and then function G, kind of that half arc, is function G. And they ask you to do G composed with F at 1 with question 50 on page 220 of section 3.4. So in this case, we're going to use the graph. And again, it's just a matter of looking at the graph. Again, my initial input is 1, and I want to first substitute that into function F. So I'm going to go up to my table, or my graph, excuse me, find where X is 1, and find the corresponding Y value. So when the X is 1, the Y value is 1. It's, if you want to think about it as an ordered pair. So F at 1 has a value of 1. That then is becomes my input. Once I get that answer, I'm going to substitute that into function G. So on the G graph, again, I go to where X is 1, and I find the corresponding Y value. Again, you're basically looking for that ordered pair. And again, in this case, it's 1, 1. So I end up with a value of 1. G composed with F at 1 happens to also be equal to 1. And again, we're using the 2 different graphs, and the notations will tell you which graphs to use. Okay, so here is function F and function G again. Question 52 asks us to do F composed with G at 4. Okay, so in this case, we start with an input of 4, okay, and we're going to substitute it into function G first. So when I substitute 4, which is my input, so I'm going to graph G. Here's my input of 4, and I need to find the corresponding value. So I have the ordered pair 2, 4. So G, or excuse me, 4, 2. I got that backwards. Sorry about that. Let me fix that real quick. Okay, you have the ordered pair 4, 2. So when X is 4, G at 4 is 2. Okay. So then I have that value, and that value becomes my input, and I'm going to input that into function F. So on the table for on the graph for function F, I'm going to go to where an input of 2 and find the corresponding value. Okay, and in this case, I would have 2, 4. So f at 2 is 4. So here again, f composed with g at 4 happens to be 4. Now, it doesn't always happen that way where you get the same input and the same output. Okay, it just happens to be the case with these two functions. All right, here's function f and function h. Function f and function h. And it asks us to do f composed with h at 2. So our input is 2, and we're going to substitute that into function f. So looking at graph h, I find where the x is 2, and I get 2, 2. So my output is also 2. So that output now becomes my input into function f. So I'm going to find on function f where the x is 2, find its partner. If you have the ordered pair 2, 4. So when the input is 2, function f gives us a value of 4. So f composed with h at 2 is 4. You can do the same type questions with equations, okay? So if you have an equation such as f of x equals 2x squared plus 1 and g of x is 3x plus 5. Then if you're asked to find f composed with g at 2, that means your input or your x is 2 and you want to substitute that into function g first. Okay, so I'm going to substitute 2 into function g wherever there is an x. So I would have 3 times 2 plus 5, and I'm going to do the math. Okay, so I would have f of 3 times 2 is 6 plus 5. Okay, I'm going to try to keep, and then, so that gives me f of 11. Okay, so now I take the answer, which I got, which was 11, and plug it into function f wherever there is an x. So for function f, I would have 2 times the 11 squared plus 1. So that gives me, if I do the math, I have 11 squared is 121. So I have 2 times 121 plus 1. 2 times 121 is 242 plus 1 ultimately gives me an answer of 243. So F composed with G at 2 has a value of 243. Now you can also do it with equations. You can actually also perform the operations with a variable, just like plain old x. So in this particular scenario, our input is actually just an x. And I want to input that into function g first. So when I input x into function g, I get 3x plus 5. Now that's an algebraic expression. And as yucky as it is, now what I have to do is take that expression and substitute it into function f, wherever there is an x. So I'd have 2, whoops, excuse me, let me get the right. I would have 2 times 3x plus 5 squared plus 1. And then I need to do the algebra to simplify that. Now, please be careful. Remember, to square this really means you need to do 3x plus 5 times 3x plus 5. And to do that, I would actually use FOIL. So I'm going to FOIL these two out first. So I have 2 times 9x squared plus 15x plus 15x plus 25. And then I still have plus 1 tagged at the end. From there, you can go several different directions. You could go ahead and combine like terms. You could distribute the 2. I'm going to go ahead and distribute the 2. Okay, so I would have 18x squared plus 30x plus 30x plus 50 plus 1. And then finally, I'm going to come back and I am going to combine like terms. So I have 18x squared, 30x and 30x makes 60x. 50 plus 1 is 51. So F composed with G and X is equal to 18x squared plus 60x plus 51. Using the same two equations, we could do something like G composed with F at -3. In this case, my input is -3, and I'm going to substitute that into function F first. So if I substitute into function F, I would have 2 times -3 squared plus 1. Okay, and then I'm going to do the math. Let's see. -3 squared is 9. So I have 2 times 9 plus 1. 2 times 9 is 18 plus 1 would give me ultimately 19. Okay. So then the value of 19 becomes my input value. So I need to substitute 19 into function G wherever there is an X. And let me make sure I remember what function G is. Function G is 3x plus 5. Okay, so then I'm going to plug 19 into function G. So I would have 3 times 19 plus the 5. Okay, 3 times 19 is 57. So I have 57 plus 5 is 62. And one more, because I want to show you something that I want to kind of prove to you that the order matters. Okay, before we did F composed with G, now we want to do G composed with F. And so again, this means that I'm going to start with an input of X into function F. If I substitute X into function F, I have the value, or I get the equation, 2x squared plus 1. So my input is now 2x squared plus 1, and I'm going to substitute that into function G. So I would have 3 times the 2x squared plus 1, that's my input, and then still added to 5. So I need to distribute. Okay, so I have 6x squared plus 3 plus 5, and I then need to combine like terms, and I end up with 6x squared plus 8. Now notice this equation, which is G composed with F, and the question back up on number 77 is not the same. Okay, whoops, messed up there. Okay, it's not the same. So typically F composed with G and G composed with F are not the same values. So hopefully these examples will help you as you go through and are looking at how to do composition of functions.